What's up, guys? Kind of messing around up here in my electronics laboratory. I have moved it back upstairs into the house. I had this stuff all down in the corner of the garage in that little room I had built, and the wife was using this room for working at home, but now she isn't. That little corner room was kind of hard to air condition. I mean, it was like this area like size right here, you know, and I had that little high wall in there, but I'd either be warm or freezing or whatever, and this is kind of my mechanical room down there. So I thought I could work in there too, but after a while kind of got old. So and I wanted like to have the TV back up and all that stuff. So I'm up here, got another desk because I gave the other one away and kind of just getting situated. I think I put this desk actually together almost 2 months ago, maybe a month and a half ago, but just now kind of starting to tinker around in here. So slowly bring up some electronics. I'm sure the wife will be real thrilled. Also, I'm gonna mess around with some stuff, you know, from AC units, try to make a little more content. I'm gonna hook up my scope to kind of see what these signals look like coming from the silk bus of a Honeywell system. Over here, you know, got like some residential guy gave me this because I don't know crap about residential anymore because I've been all commercial for over a decade. But this is out of like a Carrier Infinity or something like that. So this is your inverter power board, and I'll probably mess around, make a separate video on that. I haven't ever worked on these units, but I can recognize kind of what's going on. So anyway, I was starting to go in on that. I'm going to make a separate video on that. Brought up a bunch of my stuff. This is all my unfinished stuff. These are all good boards in here pretty much. I can power up any of these little microprocessors. Like these are boards I experimented with making myself. That one's a little crude, but it's got a little 44-pin chip on there, which is the same chip as that, which is really small. It's another one, dual. This is my dual EXV driver board, or I can use it for other stepper motors. Here's a little stepper motor board I use. It actually just powers up with 12 volts, and then I can just use this joystick to test stepper motors or electronic expansion valves. Plug them right in there and open and close them. It's pretty cool. Other little boards. These are boards that I actually was experimenting with. This has got a 44-pin 16F87 on there, which is what I have over there. I'll show you in a second. Here's one that was kind of goofed up. Or that's actually a different one. I made a couple different ones. Now, when I etch them or do isolation routing on my little CNC machine, they look like this. They just separate the copper but don't remove all the copper. Like these are made. I could take my schematic and go online and just have them made and sent to me, which is how I get these. Some of the parts I'll get put on there and then I'll add the rest. So bunches of different ones in there. This is the one like I'm running my homemade heat pump on because I've got like I think like 5 of these boards, and this one I think I repurposed. I was trying to make it control my homemade water heater heat pump just by repurposing it. But so I relabeled those relays. It's pretty cool too. It's got that same processor on there. A couple of add-on capacitors after the thought. And you notice that sometimes when you take apart electronics, you'll see where sometimes the manufacturer does that. You'll see soldered on components like this, like especially capacitors, because they have like a noise issue or something, and you'll see them add stuff just like that from the factory and sell it to you. So okay, there's that stuff. Stepper motors, some jumpers, just getting the kind of stuff up here. Try not to make a mess. Got some more magnetic things. This is my spare computer, which is still pretty good. I think that's a Ryzen 7. My main rig, my bedroom's a Ryzen 9. So this one's more than enough for doing coding and stuff. Got some electronics up here. So this is just this is what's up video. So I will make some HVAC related ones later. So that's one of those boards. And somebody made a comment on my other little quick video saying I was missing the DC bus capacitors. Well, it's because I just put DC right to this, and this is for me to experiment with. So I just have a processor. I have the gate drivers on here, right here, and I just put DC in, and then 4 MOSFETs or IGBTs, you know, and then your output. And I'm just trying to make a voltage output. Like technically I should be able to put 12 volts here and then use it, you know, like a gate driver software, you know, to kind of just drive the gates and make the pseudo inverted outputs. And then if you filter it or whatever, it might look like a sine wave almost, which hopefully have some of that to come. Of course, if you had a good load, you always do want capacitors right near all the components. And I thought I had a spot for one, but anyway, I don't. But so I'd have to have it on wherever the DC supply was. So you only need a whole bunch of DC link capacitors if you're rectifying from AC to the DC. If you already have a DC source, like say a power supply, because I'm using it for tests, I just throw that in there. I'm just going to get a little bit of deviations, you know, across the wire as the voltage goes up and down. But other than that, it'll work just for messing around. So right now I'm just looking at my 4 outputs of the processor just to kind of mess around. So I kind of show you guys kind of some stuff and where I left off like a year ago or more. Might have been, it was a while ago. I think it was more than a year. So you see what let's pause that. This is something that had a little bit of issues. Now these are not laid out conveniently because I've got it all remapped out for a different program. I'll show you in a second, but you can kind of see how, and I think I made way too many pulses, way more than I needed, but in a time period, you know, it's like shorts, and then it was getting longer and longer and longer, and then really long, and then shorts. And at the same time as you're like say this is driving negative, right? You're from negative bus to the one output, you're going to pulse. Actually, this would be pulsing. I haven't, like I said, not laid out. It's always positive, I think, that I had pulsing, and then the other side holding negative. It might have been the other way around. But basically, you're going to hold one like the negative, and then you use pulse width modulation for the positive part out. And then working together, you know, your voltage will, the average will change from the beginning of the period, after the period, you know, to recreate your AC sine wave. Kind of like what this is. This is like an AC sine wave. And then this is like a crude one with a lot less steps. You just have short, a little longer in the middle, then short. And then you can invert it, and then do short, long, short again. And then if you just kind of filter it out, it'll be a kind of a crude sine wave, which the cheap inverters just use like one pulse each, you know, for each cycle. You know, and some might do like 3, but the good ones will have a lot of pulses and then some filtering, and then it might look like a real sine wave. If you go through transformers and stuff, it kind of slows down the current anyway, smooths it out. But this is for experimenting. So this was, I think, way too much, but kind of see it. But I always had a glitch. And see on the other, here's like one of those like case where like it had like this one was like had like a longer on pulse, and it had like a long one right at the end after it completed the other little chain of varying pulse widths right there. And sometimes it did it to the other one, and I was like, what the heck? But I was just messing around using, you know, pulse width modulation. And this is just some garbage code, but I was just to make that, I was just doing it all manually. There wasn't anything varying or anything here other than just delays and changing the pulse width modulation, you know, and then just to generate that. I was using it in hopes just to drive the board and mess around with the board, but it had glitches. It also didn't have enough dead band in between there. So take this back off and run. So I have a couple different different subroutines I could jump to. So if I change it, here's like a more crude one, which is exactly what that is. And this is pretty cool. So, and I have the 4 traces kind of lined up to see what it's doing. So like you have at the same time as it's pulsing the positive half, it's got the negative of the other gate driver and another pair of MOSFETs held low. And then it's going to end, and then it's going to do the opposite. It's going to pulse the other output and then hold that positive high. It really won't work like that. I'll kind of probably pulse the positives on both directions, just switching the polarity. But I just have it like this just for the looks of it on the scope, so you can kind of see the waveform. I can get rid of, you know, the other ones, and you can kind of, if I move them next to each other, you kind of get an idea of it. But it takes 4 outputs, you know, to drive it. Because like I said, it's basically like taking a battery and you're going to hold negative to this output, and then I'm going to pulse this one. And then you're going to do that for the one cycle, and then you're going to turn it off. Then you're going to switch your power around through the electronics of the MOSFETs. And then you're just basically do the other thing. This side will be negative, and this will be positive now. And you'll pulse, with modulation, or this is just with timers, to make your varying pulses, just to make your pseudo, waveform, your average current or whatever. So this is just real simple, just with a 3-step short, long, short, and then the other direction, short, long, short. Just to mess around. I want to see what it looks like if I kind of run that through like make a 24 volt sine wave with 12 volt bus, plus minus push pulse, kind of see what it looks like, and then I can go from there. And I'm just messing around again, getting back into my code. And here's one more that goes slower. Same thing. So go back to the 60 hertz one. And speaking of 60 hertz, pause that. So basically, I'm just doing a close enough output right now. But 60 hertz is about 16.8 milliseconds for a full cycle. It's more like 16.6666667 or something like that when you kind of do a 1 over 60 hertz to kind of get your milliseconds. So round it up, 16.8-ish, is just kind of what I did to make the numbers even. Just to think in my head, like halfway through one half cycle, will be about 4.2 milliseconds into it. Finishing the first half will be 8.4, 12.6 milliseconds into it for the peak of the other one, and then the full 16.8 there. So if you add that little bit extra time, you'll actually be stretching out the sine wave, and you'll be like at 59 point something hertz. It'd be like pretty close to 60. It's just barely under. So if you're just trying to run something with it, and you weren't like, trying to get a clock base out of the sine wave or something through some other electronics, it wouldn't even matter. It wouldn't even notice. It's just so close. So, and I kind of just broke down just to kind of get an idea of like 8, I just divided it up into 1 millisecond steps just to kind of look where they would fall, just to get started. Make it really easy actually. So just do 1 millisecond off, 1 millisecond on, another millisecond off, then 2 milliseconds on, millisecond off, millisecond on, millisecond off, and then you're gonna do the same thing, but that's gonna drive the inverted output. So when you come up here and you kind of measure this, let's see if this is anywhere close to where it was. Of course it's not. Oops. So get over here right where the cycles break, and get over. Oops. So I'll just get this to about, right. So I mean, you can see it's like 59 point something hertz. If I go to 60-ish, this never goes right on 60, but you can see it's just oh so close to, it's just barely late, right there. Focus, so close enough. And then if I go down to 15 hertz, right. Let's do this and capture it. Kind of do the same thing. What are we at? It's like 15.97, more like, or closer to 16 hertz. It's actually a little fast almost. It's pretty close to 15. It's 16. Now, what I'd have to do to get that even closer is I would have to, I'm just using the high bit register, and I'm just keeping these all zeroed, I think. That's what I had it set for. And so that's where I'm getting, what it come out to. 1.2 dividing down my clock of 8 megahertz. Like I said, 1.02 milliseconds per tick of that clock is a 16-bit, register that's kind of adding up, and when it overflows, you do your interrupt and go over there. Subroutine's going to stop it. So, all right, where was I before I was so rudely interrupted by the wife coming in? So this was an old garbage code And then, just to get some pulses with just a clock, I kind of did that, which is only 1/2 of it. But then to simplify it, like here's like 60 hertz one, you know, and up here's the 15 hertz one. Here's still the 30 that you saw when I first showed it to you. So this, like, just to generate it, and it's real simple, is just using some arrays, you know. So this is just what I load, 7 steps, you know, to go through that, and then it does it again. So I just have it loading up the byte value into the high byte of the timer register, you know, and it just basically that's already at max 255 or FF for hex guys, and the low byte counter will count 0 to 255 or 0 to FF, and then roll over, and when it rolls over, you know, so that gives me about that 1.02 milliseconds, and so that's why I'm just doing 1 millisecond, 1 millisecond, 1 millisecond, 2, and then 111. That's on the 60 hertz, and then on the 15, it's like, you know, like, what is that? It's like 3 or 4, whatever that comes out to be. It goes 3, 4, 5, 6, yeah, zeros. That'd be 4 milliseconds, 4 milliseconds, 4 milliseconds, 8, 4, 4, 4, whatever I think I had, or 6, maybe it is in the middle. I don't know. That's what's generating that right there. Really simple, and then it's just my on states, off, on, off, on, off, on, off. And then I can add to that later and just easily add more steps. Real easy. It's going to make the code really simple. Just make a couple changes and just add more steps if I want to. Just a couple changes. So that's pretty cool. So I'm just messing around. And of course, I also could just do some wizardry and make it continuously variable too. But for what I'm going to do right now, I just want to make, for testing, I just make presets. 15 hertz for a slow frequency, 30, and like 60. And just use my buttons. I have my buttons here just to cycle through them. Which is not going to show you when I have this on stop, but you can kind of see the frequency difference. Yeah. So, and that's just so I can see what's going on there. I like using the LCD just for printing out whatever it's doing. So just using blinking LEDs or something. Here's a potentiometer I had built on this board, so I could just have it read an analog input right there and just vary it by doing some wizardry or whatever. So I want to go on and on with that, but that's just kind of like the real basic, you know, how that works. Took a couple, yesterday I spent till like 11:30 on the code, changing it all up, and then didn't have it working right when I went to bed. Then it came back up. There's always something you forget, and then I messed with it for a little bit today, right around dinner time, and then I saw what I did, and then it, you know, of course, then it works. Moving stuff around, you forget to put one piece of code back in, or unremark a piece of code, or whatever. So this is basically a version of C, and they call it XC8 in the microchip MP Lab software. I don't use it that much, so I'm not real fast at it. I'm pretty good at that part, just because I've always liked programming. But it's another one of the hobbies that I do a couple times a year, and I divide up my time on like 10 different things, hopping from one to another, not finishing shit as I've been getting older. It sucks. So I kind of got to finish some shit, but I do want to make like I said, maybe I'm gonna try to make maybe out of this something that just takes like 12 volts in and then makes a 24 volt sine wave out. So I could take like a battery and like run like low voltage stuff on HVAC stuff or something like that. Be pretty cool. Maybe just put a couple lithium ion batteries together. I mean, you put like 4 of those, you know, 3.6 volt batteries, you know, together. I mean, you got 12 volts that would last quite a while for just doing some testing, you know, on something. Be pretty cool. Anyway, I don't want to go too long on the video. This is just gonna be a video of just what's up. Kind of just go over a little bit of coding stuff. So for the other guys that are into that stuff, or just whoever just wants to scratch their head, this kind of shit will keep you up at night. And then I will make some separate videos of messing with some HVAC stuff hopefully soon. And just, I've been slacking on the HVAC stuff, and I know some people are like, what the hell, this is an HVAC channel, but it's always been also kind of me nerding out on cars and stuff too. Which sadly, whenever I do if I film us doing a repairs like changing motor mounts, ball joints, fixing AC or something on a car, all of a sudden I get a bunch of views. It's not even my attention. I don't have my stuff monetized or nothing. So, anyway, all right, well, that's it for real. Don't forget to like, share, subscribe, and comment. I'll catch you guys later. We'll get back to it.